Hello students. Last class we discussed about the control unit. Control unit can control either in two ways, either the hardware control unit control and or microprogram control. That is, hardware control unit is a circuit that is going to use for controlling your control unit, okay, or if you to generate the signals for any instruction, the signals should be generated. So that is going to generate by the control unit using the circuits. That is we call the hardware control unit. Whereas the microprogram control unit is a collection of instruction that is used to generate the signals. Whenever instruction is executed, the generated signal will be generated. But this is done by the use of program. That is collection of program will be done. Will do the generation of your signals. So in this class, we are going to see the fetching cycle. That is for one instruction, how the instruction is fetched from the memory, how the processor will be executed, how the processor will take the all instruction into a registers, and after transferring, after calculation or some uh, mm, execution, that is after some calculation, how the the instruction should be transferred to the main memory and will be executed. So this is a simple block diagram of your fetch cycle. You have a memory and fetch the CPU, the central processor unit, the main thing, which is used to to fetch the instruction from the main memory and executed. Okay, and again it's sent to the store in the memory. So we will see one by one here. Fetch instruction, fetch instructions, decode the instructions. Okay, then read the address from the memory and execute the instruction. This is the one cycle for one instruction. For example, you have load accumulator LDA 2080 something number is there, memory number. So for that instruction, the whole thing will be executed. That is a whole one cycle should be done for one instruction. Let us see an example here. I'm just this is a simple example. You have a processor 8085 processor. It have a resistors A to DHL HL register, and you have main thing here is a program counter register is there. This program counter will count the memory of your first memory of your memory address. It will increment it whenever instruction executed. It is incremented automatically one by one step by step. This is your assembly program. Let us see. This is your simple program. Whenever in program is executed, that program is loaded in the memory. It is in RAM. It is in not in your hard disk. It is not in your CD-ROM because processor is very fast. So that the RAM is a made up of chip for that speed, for that because the microprocessor very speed, for that speed the RAM should be equal to that speed. So this is called a primary memory. The whole program is loaded in your primary memory, and the one by one instruction is executed through the bus, system bus. The system bus will control by the processor to send the address, send the data, receive the opcode, something like, and execute instructions. After calculation here, all the things are being stored in the memory. The program is loaded. The whole program will loaded by the loader. Already you are familiar with this thing. Loader is the main thing. Is a loader is a maybe it's a program that will load the instruction of your the whole one program instruction should be loaded in the main memory. Okay. So here main thing is your program counter. This is your program counter will locate the starting address of your memory. Whenever instruction one by one is executed, it is incremented by 1. Okay, this is a simple diagram of your fetching cycle. It will fetch the processor will fetch through the bus. After some calculation, again it is stored in the memory. Okay, so for one instruction, the whole thing should be processed. That is like this. You see here, it is fetch the instruction, decode instruction, then the read the address from the memory and execute the instruction. Likewise, so loaded in the memory, it will take the one by one instruction executed by the system. It will use the system bus by the processor. After execution, again it's sent to the memory. So come to the your actually there are two cycles: the instruction cycle, fetch cycle, and execution cycle. All it is connected with the system bus, CPU and memory. So these are the two cycle are there: fetch cycle and execute cycle. Let us see the instruction. A program residing in the memory unit of computer consists of a sequence of instructions. Those instructions are executed by the processor by going through a cycle for each instruction. In the basic computer, each instruction cycle consists of the following phase: fetch instruction from the memory, decode the instructions, read the effective address from the memory, execute the instructions. Okay. Initially, the program counter is PC. I already told you PC is located with the address of your first memory instruction. Okay. The sequence of SC sequence counter is cleared to 0, providing a decoding timing signal T0. After each clock pulse, SC is incremented by 1 so that the timing signal through a sequence T0 to T2 and so on. The microprogram operation for the fetch and decode phase can be specified by the following register transfer instruction. This T0 is program counter or in the address register. So this T1, it is in T3. Those are the steps will be done in 3 cycles: T0, T1, T3, T2. At last, since only AR connected to the address input of memory, it is necessary to transfer the address from PC to AR during the clock transition associated with the timing signal T0. The instruction read from memory is then placed in the instruction register IR with the clock transition associated with timing signal T1. So this is a general flow chart of your instruction cycle. That is, it is SC sequence counter is cleared to 0, address PC program counter or the address is stored in the program PC program counter is stored in the whatever bit is stored in the address register. So likewise, this is the program counter incremented by after the instructions. The program counter is incremented one by one. It will be decoded. Okay, whether it is a register reference instruction that will be executed or memory reference address execution will be like this. After all those things, again it will go to the program counter. Program counter now is incremented by 1. It will fetch another cycle, another instruction. So likewise, it will be done after each instruction like this. You see here, this program counter is there. It will take one by one, step by step, one by one. This is a program. It will take this LDA 2080, then SIM, then move immediate. That is whatever we immediate means. This is the number input from the keyboard. Move immediate means whatever it is this number, it is loaded in accumulator like this. Step by step, it will be loaded. So like that. If it is a memory means memory reference instruction, it will be executed. Or register reference means this. Or memory reference means this. After this, again it will go to the program code next instructions. So this is the explaining everything. All those things is you read carefully one by one. Same thing it is explained here. Okay, due to time limit, I have to finish. So these are the diagram of your flow chart. You see one by one. It is not a new thing. It is same step. It is constructed in the flow chart. Okay.